We're going to deal with inverse functions. I'm just going to do a quick introduction for you. We'll spend a little bit more time with this in class. So, what is an inverse function? Well, there's 4 different ways you can look at it. First one is for every point xy from the original function, the inverse function has the point yx. So for every point from the original function, you can just flip the order, and you know that that point's going to be on your inverse function. So if you only have just a small set of points for your function, it's quite easy to find the inverse. The other way you can think about it is undoes the original function. So quite a few of you were dealing with the function y equals 2x plus 1. Well, you just want to think about how to undo it. Another way you can think about it graphically is it flips your graph over the line y equals x, which we'll switch over to Desmos in a little bit to take a quick look at that. The other thing to look at it is when an inverse is composed with its original function, it will always be x regardless of order. So if you do g with its inverse composed, or its inverse composed with g, it'll come out to x. So let's take a look at this simple example. So you have f of x equals 2x plus 1. What does it do? Well, it multiplies x by 2, then adds 1. So the order's important. So do the opposite of what it just did. So subtract 1, then divide by 2. So subtract 1, and then take that and divide by 2. And that is our inverse function. So it's not too difficult. But that's for a nice simple function. It's nice to have a better idea of what's going on, especially for those functions which you can't tell what's going on if it's a quadratic. Because what's it doing to x? Well, it's squaring it and it's multiplying by something else at the same time. So just undoing what it's doing isn't that easy. So if I give you any function f of x, you want to do the following 4 steps, and it'll always give you the inverse properly, as long as you do the algebra. So given the function f of x equals 2x plus 1, first thing, replace f of x with y. So you get this equation, y equals 2x plus 1. Then replace y's with x and x's with y's. This might sound a little confusing, but basically wherever you see a y, put an x. Wherever you see an x, put a y. So you get x equals 2y plus 1. Why do we do this? Because we're looking for something that will undo our function, so what's getting put into it was what was getting taken out of the previous function. Next step, you want to solve for y. So if you do that, you get y equals x minus 1 over 2, which we've had before. And if the inverse is a function, replace y with f inverse of x. So the negative 1 part signifies that it's an inverse. Keep that in mind. All right, now let's go ahead and switch over to Desmos. So here's our original function. F of x equals 2x plus 1. Let's go ahead and toss in the graph y equals x. And our inverse function. We can see that any point they intersect is going to be on that line y equals x. Because this has the point negative 1, negative 1. Well, that means this graph will have the point negative 1, negative 1, because you switch the x and the y's. Now, if you also toss on some few extra points, you'll notice that f of a, and f of a for some random a, well, this one is on our original function, this one is on our other function. So going back and forth, they keep track with each other. So hopefully that helps you understand what's going on with inverses. We will be dealing with a bit more with them this week. See you in class.